Welcome back. So far we've talked about standard form and naming polynomials. Now we're going to talk about the end behavior of polynomials. So what I mean by end behavior is seeing where are the ends of the polynomial facing? Are they facing up or facing down? So whenever you're talking about end behavior, you're going to have two names for it. One based on what it's doing to the left, one based on what it's doing to the right. Now the cool thing is, all of them are based on things that you actually already know, based on x squared and based on x cubed. Let me show you what I mean. So, x squared, y equals x squared, you know that basic shape. You know, it's face like that. So I want you to think that that is an even power. And the leading coefficient is positive. The x squared has a positive term in front of it. So for every even powered function, so x squared, x to the 4, x to the 6, the ends will actually all act exactly the same. The in-betweens are obviously going to be doing their own things, but the ends are going to act in the same way. And what I mean by acting in the same way is notice it's going up and up. So that's where it gets its up, up designation from. Both ends are facing upward. And again, every one will work that way. Every even polynomial's endpoints will work that way when it's positive. So when you see this, x to the 4 plus 3x minus 5, you can think to yourself, hey, even power, positive, so I should be getting a rough shape like that. Oh, all right, that's facing up, up, just like in the graph above it. All right, now, the opposite is true when it's negative. So look at that. So this time it's an even power, but it's negative. So it's actually facing downward, which again, you should know that basic shape. You should know that negative. We'll flip it down on its side. And notice, so now it has a down, down designation because both sides are facing downward. And that same thing holds true for every even powered polynomial. So here, notice, that has degree 6. That 6 tells you it's going to act the same way as a parabola. So when you see that and you see it's negative, you should think, oh, all right, it's going to be an upside down, even power function, even, thinking parabola. All right, down, down. All right. Now, thinking on the flip side of things, so the other pattern you'll see is an odd pattern. So what I just did was describing the even pattern to you. Now we need to think about what will happen for the odd pattern. Odd pattern is going to follow x cubed. And x cubed is just a little blip, just like that. Okay? So this time I want you to think that x cubed is facing down and then up. So it gets what's called a down-up end behavior. And just like before, every odd power will work that way. X, x cubed, x to the 5, x to the 7. Anything that is an odd degree, those are going to work the same way. The endpoints are going to be acting the same. So when I take a look at this one, I see an odd degree. So I think to myself, all right, it's going to follow the x cubed pattern. So down and then up. And that's all you have to do for the naming scheme. And the final one, well, What if I have my cube, but it's negative? So now notice it kind of flips it down on itself. So now it's coming downward instead of going upwards. So this side is starting up and then ending down. So that's where the up down name comes from. All right. And again, every odd power function will work that way. So I see the odd there. So I think, oh, it's going to be the reverse cube because it has the negative there. So I draw a rough sketch of the negative cube. And then I look at those endpoints. So it's starting up, ending down. That's all you have to do for the naming scheme is tell me up, 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 down, down, up, down, down. You just have to name it for me. All right? So let's get a little practice in where it's not already labeled in a nice chart for you. So for this one, I see a negative odd degree. Okay, it's an odd degree and it's negative, meaning that it's going to be that upside down, that reversed cubic function. So I expect to see a rough sketch for you, okay? You have to do a rough sketch for me because that's what's going to show you starting up and ending down. So you get the up-down behavior. Here, I see an even power, meaning is going to follow a parabola, and it's positive. So that's going to have a basic shape just like that. So again, I expect to see that rough sketch because then you can see up, up. So for all of these, I should see a rough sketch showing so you can show me that you understand that you're connecting it to either a parabola or to the cubic function, and then actually give it the proper name. All right. So once again, here's the end of our notes. So make sure you have all this written down for me, and then make sure you come and see me if you still have any questions on these end behaviors.